All right, the next day here now, and beautiful. Nice sunny day. I accomplished quite a bit off camera, and I don't want to make this video any longer than they are now. I got this at Harbor Freight, and it's helped me quite a bit holding small things. A little tedious trying to get the thing angled right so you can see something. And I got my fuse in here. This is a 15 amp main fuse. And I put the terminals on and I soldered them. And I made some changes since the last video. Like, my projects, they change as they go, usually for the better. The relays are not going here. The terminal strips are going here. And the relays are going up here. And I'll show you what I did. I got a 1/4 inch piece of Luan that I happen to have in the shed. And it's going to be mounted in here, like that. And I put a block of wood right here. And I used carpenter's wood glue, glued it to the cardboard backing, and then put masking tape over it to hold it in place. And that will be for the screw that's going to go in here so I can pull it in and out. Okay, so it goes like this. Okay, so the two relays for the left and right head movement are going to be on this board, nothing else, because there is no room for anything else. And the head motor and the mount trigger fuses will go down here. Then the rest of this down here will be for terminal strips. Now, Steve sent me some terminal strips, but I've had these, and you have to solder from the back. But these have 8 in them. So I have this is one I got from Steve. But I'm going to have 16 wires coming out of here. And I'll show you what I did. Using the wires that Steve gave me, hookup wire, I bought some soldered terminals at my hardware store this morning. And I was going to solder them in. But it takes me so long to solder because of my eyesight. And I sure missed my soldering station. Like a stupid idiot, I gave it away. I gave it away to the fellow that was running the auction, Bill Morris. I had a nice Weller, temperature controlled. Beautiful job that thing did. So I'm using this one, which is pretty good, but you got to leave it run for quite a while to get it up to heat. And I didn't have any decent solder until I found this. I brought this from my workshop. There's 5 pounds of 50-50 solder. I think it's 50-50. Maybe it isn't even. It's just rosin core. I had this for about, 40 years. And I'm sure glad I didn't give that away. And then I got the Alpha. That's not as good. That was in my toolbox. All my other solders are gone. Probably donated to the auction or whatever several years ago. So I went to my hardware store, and I have one of these, and I don't really like crimping them, but this worked pretty good with the ones that don't have the plastic on. Under a powerful magnifying glass, I can see that the wire is crushed right in there properly, so I did not have to tin them, and I did not have to solder them. And I had 16 of these to go. 8 connections on each relay. I am not 100% sure if I'm going to be using all the contacts on the relay. The pins are marked on the sockets, but you really have to take a powerful magnifying glass to read it, because they're embossed, raised letters in plastic, the hardest things for me to read. So I put a black dot on the coil. Pins 2 and 7 of the relay is the coil, 12 volt. The rest are normally open, normally closed contacts. So we're going to be using 2 relays on this board, but before we even put those in, we're going to run the wires down, and I'll show you how I'm going to do that. I'll just push a wire in here and I'll show you how it's going to be mounted. Each wire will come up through the hole from the back. Wire will be bent over, and each connector will be under each screw. So the holes are lined up with each screw, and it'll be on both sides like that. So I got 16 holes drilled in here. And we're going to have a bunch of these black and white wires coming out the back side of this board. All these ends here, of course, are going on the relay sockets, and these ends will be open for now until I find out what wire is what, and I got to trace them back and so forth using an ohm meter and so on, and we'll get that so that I know which one is which, and then we'll wire them in. 2 terminal strips that'll be put here, and another terminal strip of some sort, or a socket of some sort, where the remote control will plug in. Alright, it took me a while to do this. Bad eyesight, you know, and all that good, unhappy stuff. Well, this is how it is. Kind of a rat's nest, isn't it? But you get the idea. Now, the 12-volt coils, of course, will have a common negative. And the left and right switch, which is going to be on the remote control, will activate the relay coil. In this case, the left motor, or the right turn motor, and the left turn motor. So the positive will be coming in here. These will be tied together to the common negative, which the whole thing is going to have a common negative, doubled up in the remote wire, which the wire I got from Steve is the same gauge as this, which is 18 gauge. So the only thing we got to do is ohm out all the rest of these to correspond to the connections on the relay. And the relay has 8 pins to it, 8-pin octal if it's in here. Pins 2 and 7 are the winding, and pin 1 is normally closed along with pin 4, and pin, my eyes are bad, pin 8 looks like it's normally closed with pin 5. Anyways, I have to, what I'm going to do is to draw this out on a big drawing so I can read it without having to pick this relay up every time, and then we'll mark the pins down as to what they are. Now, you always count, like a vacuum tube, you always count from the keyway, which with my eyesight I can't even see the keyway. Here it is, right here. So this is pin 1. Let me get something to point with. This is pin 1, this is 2, 3, 4, 5, 6, 7, and 8. So that's how you read. I may be out of focus. I'm using the Kodak, so it's probably blurred, but you get the idea. So you always count the pins looking at the bottom, not looking down at the socket. It's just opposite. So in other words, if you were reading it from the top, this would be pin 1, 2, 3, 4 counterclockwise. Whereas if you're looking at this in the keyway, it's clockwise. Quite simple, actually. But with my bad eyesight, I can screw up very easily, so I'm going to do a lot of double checking and so forth. But I did want to give you this here, and then I want to show you, I'll just hold it in there and show you how it'll go in. I'm not going to mount this. And it's removable by one screw right here. I didn't do a very good job of centering that, mainly because of I didn't move this over enough, but not a big deal. One sheetrock screw goes in here and goes into that block of wood that I showed you on the back over there in the chest area. So it goes in there, and this whole board can be removed, which I want to do should I have to do any changes in this or anything. Mostly you'll just plug in a relay. But if you're not using the exact same kind of relay, then you have to rewire this. But I got 3 relays, all with 12-volt coils from Steve, and they are all the same. The only difference is I got 2 gray sockets and I got 1 black socket, but they appear to be the same. So, okay, I'm just holding this in place now, and I got to dress the wires so that they don't go on this block back here where I got to put the screw. But all the wires will come out this end here, and it'll just go down in this valley down here. There's a hole down here where the battery used to be. You're probably wondering now, hey, didn't he say he was going to have an I-motor battery, a 6-volt over here? Well, yes, he was going to do that, but we changed the design again. So we decided, I decided, I don't know, I use that term we. It was me, myself, and I, okay? I decided that we don't need the D.I.Y battery over here, that I can utilize this space for the relays and then just put the terminal strips here. Because if I was going to put the relays here, I'd have almost no room for maybe 1 terminal strip. And that would not be too good. So this is going to stay out for now, because what I have to do is to trace it all out and try it outside of Dorkel and see how it works. Now, we still need to drop the voltage on the motor, or you'll use the speed control, which I ordered from Amazon. And Ramham had a good idea. He said, well, why not just leave the control in Dorkel body? And you know what? The speed control, I might just do that. Because if I'm doing a skid, I can reach around and I can adjust the speed control. That particular speed control that I ordered from Amazon has what appears to be maybe 18 inches, maybe even as long as 2 feet. Plenty long enough potentiometer wire for the speed control. So I can mount that on the back here somewhere, and when I'm doing a skit, I can just reach around and change the speed. I don't need to do that on the remote. Although it would be neat to do it on the remote, but that means I'd have to run 3 wires from the, looks like it's got 3 conductors, which is a potentiometer would have 3 conductors anyways. So unless it uses a common negative, which I can share with the common negative here, then I can get away with only 2 wires and tie it in the remote wire. This, as I said, will go down on the terminal strip here, but right now
I'm going to have to open up a can of whoop ass on you now.
I can't do any trying out or anything right now with the wiring, because it took me quite a while to do this, especially putting them connectors on. But this particular wire here is, it looks a lot thinner than 18 gauge. But what I think the newer wire, and compared to the real old stuff, the old stuff had big, thick insulation. And the gauge of the wire, I put it through the wire stripper, and as close as I can read it, it's 18 gauge. If I put my wire stripper on it and set it for 20 gauge, it digs into the wire a little bit. I used to have a wire gauge. I used to have a lot of things, believe it or not. Believe it or not. Okay, so I even have one of my Weller soldering sponges here. It's about the only thing left of my soldering station. So that's the story there. Yeah, I like this solder. I had this solder since the early 70s. A B rosin, it says. Nassau. Nassau Smelting and Refining Company, Staten Island, New York. I thought it was 50-50. It isn't. It just says pure white rosin core. But anyways, it's really good. It's heavy. I used to have thin solder, which was for very small work, but this works out pretty good. My problem is with my irons, being outside, you get a little breeze and it cools these things right down. Today is almost no breeze, but this is, I think this is a 47 or 50 watt here. This is one of my old ones that I used to use before I had a soldering station. I got the soldering station in 1982, 83, thereabouts. But anyways, and here's some more solder here. But a lot of this solder is not all that good. But I like this, and I'm so glad I didn't give this away. But you know, it gets very frustrating trying to see this small stuff, and even looking through here, I still have a hard time. But I did it. This was the hardest thing. Wiring, getting these connectors on, and they actually went on. If I had to solder each one of these, I'd still be doing it until next week. But I didn't solder these. This wire is so good that you stick it in the connector, and it fits snug in there. And then you crimp it down, and then I look at it with a magnifying glass, and I can see it's crimped down real tight, and it is not going to come out. Whereas I use a lot of this wire here in the past, and the conductors are so thin. I mean, probably 22 gauge, something in that order. And it's the connectors, they either don't stay on or the wire bends back and forth and the connector falls off after a while. So I'm so glad Steve gave me this wire, because this is the gauge that's perfect for this project. All right, enough chattering here. I'm going to see if I can do a little more, because as the sun sets in the west, the old 64 goat wishes you the best. Thank you for watching.